This integral here, it's an integral of a rational function, and we're going to use partial fractions to decompose it into easier pieces so that we can integrate each of the easier pieces. So the function we're integrating, it's 1 over x times x plus 1 squared. According to partial fractions, that's going to decompose into something over x plus something over x plus 1 plus something over x plus 1 squared. Okay, we do have two pieces corresponding to that factor of x plus 1 because the x plus 1 is a repeated factor. And since it's repeated twice, there's two pieces. Okay. We can use the cover-up method to figure out what goes above a couple of these. To figure out what goes above the x, we'll cover up this x, we'll plug in x equals 0. If you did that, you'd have 1 over 1 squared, which is 1. So 1 goes there. We can also use the cover-up method to figure out what goes above the x plus 1 squared. We could cover up the x plus 1 squared, plug in x equals negative 1. If we did that, we'd have 1 over negative 1, which is negative 1. Okay, so we can use the cover-up method for those two. Unfortunately, we cannot use the cover-up method to figure out what goes above this x plus 1 because you'd have to cover up only one of the x plus 1's here, and then you would not be able to plug in negative 1. So cover-up does not work here, so we'll do the next best thing. We'll just call it a. Okay. Now we will solve for a. We're going to take this whole equation here. We're going to multiply both sides by this big denominator, the x times x plus 1 squared. If we did that, we'd have a 1 on the left. We'd have 1 times x plus 1 squared plus a x plus 1 minus 1 times x. Okay, when we multiply all three of these fractions by that common denominator, different things cancel each time. All right, now let's go ahead and multiply out the right-hand side. Let's see, if I multiplied this out, so I'd have an x squared plus 2x plus 1. We'd have an ax squared plus ax, and then minus x. And we could combine the like terms. X squared and ax squared would combine to give you a plus 1x squared. You also have 2x, ax, and minus x. If you combine all those, I think you would get a plus 1x, and then we also have a plus 1. Okay. Now you compare the coefficients here. Notice that on the left-hand side here, there is no x term. There's also no x plus 1, or there's also no x squared term. And so what that means is that both of these coefficients must be 0. So a plus 1 must be 0, which, both of those basically tell you that a has to be negative 1. Okay. So, so now we've got our decomposition. Now we're ready to integrate. So the integral of this function, we can actually split up into three separate integrals. We can split it up, the integral of 1 over x dx. Since a is negative 1, the next one would be minus the integral of 1 over x plus 1 dx. And then the third one, again, would be minus the integral of. And what I'm going to do with this one, instead of writing this as 1 over x plus 1 squared, I'm going to write it as x plus 1 to the negative 2 power. Okay. The reason we do that is because when we integrate, of course, the first two are just going to be natural logs. We're going to get a natural log of x minus a natural log of x plus 1. But then the third one is not a natural log, because the third one we should use the rule of increasing the power by 1 and dividing by that number. So if I increase the power by 1, the new power would be negative 1. Dividing by negative 1 would basically turn this minus to a plus. So we'd have plus x plus 1 to the negative 1. and then plus C. Okay. Technically, you know, we were doing U substitutions on these two. We were letting U equal x plus 1, but I just didn't write out the details.